My name is Ivanna. Today I'm going to talk about how can you manage APIs deployed inside of the Google Kubernetes Engine using the cloud endpoints. I will cover different approaches, topics, I don't know, whatever that you can use there. Let me just say a couple of words. Give me a second. Okay. Let me just say a couple of words about myself. So I'm working as the Java engineer slash tech lead for 10 years now. Last 6-7 years I worked for a company called NIX, and it's funny because when I joined we had a party because I believe there was like 200 or 300 people working there, and now on this slide you can see that there's like more than 150,000 people working here. So nice company, growing, having a lot of offices in different countries. Just go ahead. I know there is a lobby for NIX where I'm sure you can get more information and maybe even some prizes. Okay, now a small organizational thing. I will try to follow up on the chat, so if you have any questions, post them there. I will be checking once in a while and be trying to answer your questions as we go. If I will see that I'm running out of time, I'm not able to finish my presentation, I will stop answering those questions. Sorry, but we can then follow up in the discussion after the presentation itself. Okay, that's all for introduction and organization. So now let's get started. First of all, I want to talk about the Kubernetes terminology. Even though it's not like the main part or main focus of this presentation, anyway, I'm using a lot of terminology, a lot of things that Kubernetes provides on its own. That's why I would like to spend the 3 minutes just to check like main important things you need to know to understand what Kubernetes is and really get the point of all of this presentation. So first of all, you need to know that the Kubernetes itself is a cluster, and it consists of worker machines. VMs, it can be Docker images, by the way, Docker containers, sorry, if you run locally, but normally those are VMs or something else. And normally they are called as nodes. So if I'm saying node, I mean the virtual machine that is part of the Kubernetes cluster. The next important part is called a pod, represents set of running containers on your cluster. To say it like less complicated, that's basically an instance of your application. So if you have a service and you want to deploy it, you then pack it in the Docker image and you create pod using the Docker image. That pod would include some information like where to download this image, as well as some additional environment variables, liveness props, readiness props, and other stuff. But the pod is like a smallest item inside of the Kubernetes cluster. Then pod itself, they are not long-lived. So in case you hit any error, you're gonna have memory leak or whatever happened. When your pod is crashed and deleted, it will not be restarted. That's obviously not the behavior you wanna have in your production environment. That's why there is an abstraction layer, which is called a deployment, and it's responsible for managing replicated application. What does it mean? Basically, on the deployment, you're gonna say, I want this type of pods, and I want that many of them. And then it's responsibility of deployment to make sure that you have exactly what you're asking for. So normally you would go with at least 3 pods of the same application, just to make sure that you're highly available. And even if one pod is being deleted because some error or maybe resources problem, deployment will take care to start another one pod, another instance of your application to make sure that it matches to the number of pods you want to have in your production. The last one I want to talk here is service. They are used to group and expose pods as a single application. So what's the main purpose of that? If you have a couple of different applications running inside of your Kubernetes cluster, they need to communicate to each other. Well, normally they would have to communicate with each other. And as I said, pods don't live long. So it might happen that your pod crashes. That's why you don't want to make a connection from pod application 1 to pod application B just because it's insecure, not insecure, just because it can fail. So you then introduce another level of abstraction, which is called the service. And service groups together all of instances of your application, pods, into a single entry, let's say so. This means that if you are trying to do the REST call from application 1 to application 2, you are not doing calls directly to a pod, you are doing a call to service, and then service would route those requests to a live running and a live pods. That's first responsibility of service, so to group pods to be able to communicate with them, and then service also gives another important thing, which is exposing those pods. So based on service type, your pods or your application can be exposed in different levels. So service can have 3 different types. The first one is called a cluster IP. It's private IP address. That means that when you have a service of this type, that service get assigned an IP address. This one is private. It's available only inside of your Kubernetes cluster. So services can communicate with each other inside of the cluster, but if we try to access it from outside, you will not get anything, obviously. The second type is called node port. That means that your service gets a specific port on each node IP. So if you create a service with type node port, and let's say you have 3 nodes running, it means that each node will have a certain port opened and associated with that service. So if you will be accessing that IP address of node with that port, it will route all of requests to your service. So with this, access to your application is wider, right? Because it's not only inside of your cluster, but it really depends on what is access to your nodes. Because if it's private, then again, you don't have anything more than you had in the cluster IP. Maybe it's allowed to access it from your VPN or with the public internet. The point is that you get a port on node IP. And the third type is load balancer, quite straightforward. You set up service as load balancer, and the service gets a public IP address, and obviously then you can access it from anywhere you want. Okay, that's everything I wanted to cover about the Kubernetes. We'll come back to the terminology a bit later as we go through the presentation, but at this point it's enough. I don't see any questions in chat, so I assume everyone is good, so let's go to the next slide. Problem statement. I think that whenever we talk about technologies or tools, frameworks, we need to start from the problem statement, understanding why are we supposed to use them, how they help us, and which problems would they solve. So our problem statement, what we have a Kubernetes cluster, GKE, and Google Cloud Platform. So one more word about the Kubernetes. So it's a technology, but then different, and you can have your Kubernetes cluster on your own hardware, but cloud providers like Google do provide their own solutions. For example, managed solution for the Kubernetes cluster in GCP is called GKE. So whenever I'm saying GKE, I really mean just the Kubernetes cluster, but in Google. So that's one. The second one, we have a couple of applications deployed on the GKE. Well, because I'm a Java engineer, those are Java microservices using Spring Boot. They have some functionality. I don't know, it doesn't matter what. They have some APIs. What we want? We want our APIs to expose, secure, and monitor. It's kind of normal task that I'm sure we all did in our life. So what is important for us? Security. So we want to make sure that the logic for authenticating and authorizing a user is not copy-pasted to every single microservice or maybe move to one microservice, but we have it on a higher layer. So whenever requests are getting to our application, we know that they are secured. We have some user identity already associated with it. Also, we want to monitor our APIs. Obviously, we want to know about any failures or problems they are getting. That's why it's very important for us to have certain level of monitoring to be able to track how many failed requests we had and so on. and then expose. We want to expose our API in managed way so we can control who can access them, so they have a nice DNS URL and so on. And another, I would call this an acceptance criteria, it has to be a managed solution. The other requirement for this particular problem statement, it came from the project I'm working on. I know there are many solutions that we could kind of implement on our own. Our purpose was to have the managed solution so we don't spend time on actually then supporting it. So those are the problem statement. Those are like an acceptance criteria that we have for it. And now let's check how can we do it on the GCP itself. So obviously, the first thing you would think is an API gateway, because what I have explained is kind of exactly what API gateway does. So GCP does provide the API gateway support. It's called an API gateway. The problem with that solution is that on GCP, it's available only for serverless solutions. And because our backend API is located on the GKE, we were not able to use the API gateway. That's why this solution wasn't acceptable from us just from the beginning. The second solution that GCP provides is called an Apogee API, which also fulfills all of our needs as we need it. The problem we had with it was pricing. I cannot say it's expensive or not expensive. I know that at the point we were developing, we realized that the pricing of Apogee API was way too high for us. For me, it looked more like that this is, if you're writing some API that you plan to monetize, then probably Apogee API is the right choice for you. But in our case, those were just APIs that were supposed to be used by our system, like different front end and mobile application. That's why just the pricing didn't work for us, and we started looking for another solution. And the last one that we found on the GCP is the cloud endpoints. And the spoiler alert, that's one I'm going to talk about next. It does support integration with the GKE. It provides out-of-box monitoring functionality. You can have security on the level of the cloud endpoint, so you don't have to bother yourself inside of your services about it. And the pricing was acceptable. There is actually free quota usage. If you extend it, then you have to pay, but I don't remember the numbers itself, but it was acceptable for our products, so we decided to go ahead and use it. Okay, still no questions in chat, so I'm going to the next slide. What is a cloud endpoint? How does it look? First of all, it consists from a couple of different components, let's say. And the first component is called the service. It's an open API configuration. And that configuration includes, first of all, a unique service name. We'll have to be able to distinguish between your services. The second is DNS configuration. It's actually optional, so you might include your DNS or you can configure it in any other way you want, but at least they have this capability for you to do. And then API and security definition. And because the cloud endpoint service is an open API specification, that's like very straightforward and easy, because I think we all at least once try to define our APIs using open API specification. Here I have an example that's a screenshot, so you can see it's a YAML format. You add some attributes like info, title, and so on. The one important one is host. It's a name of the cloud endpoint service, and it has some special formats. So you can see that first you have the name, whatever you want to put, then you have endpoints, then you have to put your GCP project ID, and then the suffix was Cloud Google. That's the standard approach for naming, so you just basically put the first part as you want, and then the last part is standard, and you just have to follow that standard. Next one, on line 6, there is configuration of DNS. As I said previously, it's optional, so you do not have to use it. It includes two attributes, name and target. You can see, it might be a bit confusing, but a name in this DNS configuration is same as the host. you can change it, so you can use your own. If you have SSL certificate or domain, you can use your own. But the thing is that what is tricky. So if you have this X Google endpoints, you will be able to access your APIs using that URL that you have in name, which is basically the same as what you have in your host. But if you define just host without DNS, then this URL will not work, because what is called host is actually just the name of the cloud endpoint service. And then the second part of the Google endpoint is target. So you have to specify IP address of your API, so it knows where to route your requests. And the last part is pass. I didn't add much information here. I'm sure you've seen that before. So as an example, as this is a Spring Boot application, I've put there actuator/info. We can see that this is a get operation. We set the operation ID on it, and then we also can define response codes available for that API. Here as well, you can define the security definitions based on Open API standard. I didn't show that in example here, but it's like the same way you would do it just in Open API. So that's first part, it's Cloud Endpoint Service. The second part is called ESP, Extensible Service Proxy. It's deployed as a sidecar inside of a pod. Okay, I need to come back to Kubernetes pods a little bit. So your pod normally would contain only your application, so one Docker container. And that's kind of a best practice to put one application inside of one pod. But it's also normally to have your pod contain two containers. For example, an ESP. You are deploying two containers, one your application, and second this ESP inside of your inside of your Kubernetes pod. So it's fine to have one or more Docker containers. My point is that normally you don't deploy two application containers there, but it's fine to deploy application container and then some additional stuff like ESP, or maybe, I don't know, Prometheus monitoring is also deployed as can be deployed as a sidecar. Okay, so it's deployed as a sidecar. And it enables cloud endpoints to provide API management features. What it does, it receives requests. So when someone is accessing your application, they really call this ESP. Then ESP does all of the magic, like verifying that request matches to the one you provided in the Open API specification. It does validation of any security headers if you have any. It does logs all of the requests, so later on you can see those on graphs. And if everything is fine, then it forwards this request to your backend application. So you can see below is the image. That's an example of definition inside of the pod. You have the name of container ESP. Image itself is coming from gcr.io. This is a URL for Google Docker Hub. So this image is maintained by Google itself. And then below it, there is some configuration. First of all, you state HTTP port, so on which port ESP will be listening. Then backend, to which port it will forward request to your application. As they're deployed on the single pod, they are using localhost. Then you have a service. So ESP is connecting to the service that we've been talking on previous slide to be able to get this Open API specification and actually validate requests according to it. And the last one, rollout strategy managed. What is this for? When you deploy cloud endpoint service, you can deploy it many times, and Google would save all of the history for you. So you might, I don't know, use it for rollback. So you just decided to do a release, you deployed a new version of your Open API specification, and it appears it's not working, so you can roll back to a previous one. So with this rollout strategy, you can specify which exactly version of the endpoint service to use. Or if you put it as a manage, it is going to use latest. Okay, that's all of the theory about cloud endpoints. Let's go to the next slide. Here I have a diagram showing two applications, foo and bar. Yeah, I spent a lot of time thinking about names for those applications. They both run on the GKE cluster. Each of them have 2 pods each. You can see, well, normally I would put 3, but because there's limited space on this slide, I have only 2 pods of each one. You can see that each pod has a single container in it, and it's your application container. And then there are 2 services of type cluster IP, meaning they have a private IP address that is private to your GKE cluster. So how this will change if we introduce cloud endpoints? First of all, now we change our pods and we deploy 2 Docker containers there. Now each of your pods has an application and ESP container running there. And as well, on the right, we have defined 2 cloud endpoint services, one for foo and one for bar, and your ESP containers are connected to it. So pretty much the same I was talking about in previous 2 slides, but now showed on the diagram. What is interesting here? So we have the functionality to manage our APIs, because cloud endpoint would verify for us the APIs are correct and would verify security and would monitor any calls that are happening to our apps. But it's not exposed. I mean, you can see it's only cluster IP, so you can use it only inside of your GKE cluster. What can we do to actually expose it? The easiest way is to change the service type to load balancer, meaning that both of the services will get their own public IP address. And here you go. Now you have a public IP address you can hit, and then the cloud endpoint would provide all of other functionality. What I don't like about this approach, because every application has its own IP address, no single entry point into the system, which is kind of fine, right? But as a result, DNS cannot be configured, can be configured only by subdomains. So you cannot have example.com/foo. You can have only foo.example.com, which is fine, right? It's not a security leak, it's not something extremely bad. That didn't work for us because anyway, the APIs we're exposing were still a part of one system, so we really wanted to have one name and then route traffic based on the paths. That's why we started looking for other solutions. How can we adjust it to meet our needs? Okay, checking chat again, and it's empty. It's either everything is clear or nothing is understood. So post your questions if you have any. If anyone worked with Kubernetes before, when I said that I want a route based on the path, you would say me like, hey, just go ahead and use Ingress. That's exactly how my thinking process worked too. So let's talk first of all about the terminology. What is an Ingress controller and Ingress resource in the Kubernetes, and then how it can be used together with Google. So Ingress controller is a specialized load balancer that accepts traffic from outside and load balances it to controllers. It means that you have service, its type is load balancer, it receives all of the traffic, and then it knows how to route it to services and other services inside of the cluster. Ingress resource, routing rules. So you have this one controller that has the public IP address and you are able to access it, and then Ingress resources are just defining so which paths or which, based on other attributes, are supposed to go to or to which service inside of your cluster. GKE does provide, Google does provide their own managed solution for GKE Ingress. It's a built-in and managed Ingress controller in Google Kubernetes Engine, and it deploys Google Cloud External HTTPS Load Balancer. It does it on your own with almost zero interaction from your side. So I honestly think that you can just start and create Ingress resources, and everything will start working as magically without much interaction from you. So let's see how our diagram would change. That's the one that we ended with the cloud endpoints. I did make pods smaller, but we still have two containers running there for application and for ESP. They are linked to the cloud endpoint service, and you can see that the service is still load balancer. So if I decide to use GKE Ingress, this is how our application is going to change. So first of all, you'll have a service Ingress of type load balancer with a public IP. It's not something that you have defined. Google will do it for you. I just put it in this diagram for visualization so we understand the whole flow. Then for each of our application, we create Ingress resource that defines rules, pass rules about when to route, which request to route to our services. And the last important thing that on your service, you have to change type to node port. Reminder, node port means an open port on your GKE node. The reason you have to do it is because that's the way how GKE Ingress is implemented. So if you want to use that, you have to define your services as node port. If you ever decide to use different Ingress controller and not the one provided by the Google, you can define it as the cluster IP, so it's different. So it's just a requirement of the Google if you use the GKE Ingress. Why I don't like it? So first of all, we get what we want. So we can route bypass. We have this Ingress resources, and we can say example.com/foo and example.com/bar, so it's fine. Now, what I don't like, every application has its own port in GKE node, which again, this is kind of fine, right? There is not a big deal with it. It can be slightly complicated to manage because if you want to keep track of all of the, keep the mapping, so you want to say, this service will have this IP, then this service, not IP port, this service will have another port. You just have to keep track of that, and you need to make sure that they don't intersect. Again, fine, but might be a bit messy if you have 100 services and you just need to understand which server is serving on which node, on which port. What I really don't like about this approach, and what was a showstopper for me as I was developing that, is that GKE nodes should have public IP address. It might be fine for someone. It wasn't okay for me because I prefer not to expose nothing from my backend, because I don't want people to know what type backend I'm running, and especially I don't want to know them how many virtual machines I have and what public IP addresses they have. And if you are using GKE Ingress and if you are using a node port, it means that your VMs, your nodes have to have public IP addresses. Maybe that's an overkill that didn't work for me. That's why I've decided to move further and looking for other solution to kind of get what I want. So this approach didn't work for me too. And also, as a side note, I would like to mention that every application can be accessed in two ways. So there's a proper way when you go in via Ingress controller public IP and specifying the path, and it gets routed to your service. Or if you have your VM public IP address, you just hit it at the port and you can also access your application. It doesn't change much. It's not neither a drawback or an advantage, just mentioning it here so you understand what is the flow. Next I started looking for other options. How can I expose this API so it fills all of my needs and I still get the functionality of monitoring and securing that the Cloud Endpoint provides. First thing that we need to know is called the VPC Native Cluster. So small terminology, VPC is a global private isolated virtual network partition. I honestly copy-pasted that definition from Google site. Really what it is, it's your private network. So on GCP, when you create your project, you have a default network defined for you, but if you want, you can change it. Basically, it means that for every region, you define an IP ranges where, from which IPs will be taken when your virtual machines are created. And now in VPC Native Cluster, pods and services IP addresses are natively routable within the cluster VPC network. What it really means that is IP addresses are assigned using IP ranges in VPC. So when you define your network, and let's say you are saying, okay, so if I'm creating a VM in US East 1, please give me an IP address from this range. But also you create 2 additional secondary IP ranges and assigning them for services and pods. And now when you deploy anything in your cluster, service or pod, it will get a private IP address, but that IP address will be part of your network. So if you go to your VM and SSH there, you can actually from your VM or any other resource on the GCP in your project, ping your services on the pod and service. So you're kind of getting in that mixed mode when everything is kind of private and inside of the cluster. But because this is the same network, they are accessible like in that network from different resources running there. So that's the point of VPC Native Cluster. Now, load balancer. Okay. GCP Load Balancer. First of all, GCP provides a couple of different options for load balancer. You can have HTTP, TCP, internal, external load balancers. Because I want to expose my API to globally, we were using HTTPS global load balancer. And really, load balancer is not just one component. It consists from many components. So 2 next slides will be talking about how does the load balancer looks. And this is like first part of it, then we'll see like second part of the whole flow of the load balancer. So load balancer starts with a component which is called forwarding rule. It routes traffic by IP, port, and protocol to target proxy. Doesn't do much. It's just basically a link between certain IP and port that you define and the target proxy. Target proxy receives request, evaluates it using URL map to make traffic routing decisions. First of all, if you are using HTTPS, this is the level where you do configure your SSO, so you import certificates and private keys. And SSL termination is happening on this level. Whenever other requests go further to URL map and other steps, you don't care about HTTPS anymore. That's because the target proxy is the level where you actually terminate it. And then target proxy uses URL map, as I mentioned, to make traffic routing decisions. URL map is exactly what its name says. It defines routing rules based on HTTP attributes. Pretty much as the Ingress resource does when it says that if /something goes to this service and then /something else goes to different servers. URL map does the same thing. The difference is that this is a Google project and it actually can define a number of things where your request can go to. Now let's take a look closer about the URL map and where it can route its requests to. Right after the URL map, I say that you have a level of abstraction, which is called backend bucket or backend service. And you can define it like as many as you want. So you can have a lot of routing rules defining going to different destination. Backend bucket is quite straightforward. It's an abstraction to link URL map and the storage bucket. So if you need to serve some files like, I don't know, policies, documentations, agreement, whatever, you can just place those files on the storage bucket and via backend bucket map it to your URL map, and that's it. Now you have your nice URL and you can access those files. When it comes to the backend service, it's slightly more complicated because after backend service, there is kind of another level of abstraction. So we can route, not forward, either to instance group or to network endpoint group. Let's take a closer look on it. So instance group. Let's say you have an application, you have a couple of virtual machines, Tomcat running on them, and you have deployed the var files to them. They exposed on certain port on those VMs. You can group those VMs together as the instance group and make URL map via backend service to route your request there. So if you have an application that is still running in VM, like here you go, just use this instance group. Another thing that backend service can route to is the network endpoint group. And here we also have a couple of different options to choose. So first, network endpoint group can be zonal, and it's actually used by the GKE. So if you want a route request deployed inside of your GKE cluster, you're going to choose the zonal network endpoint group. The second option is serverless. So if you're running App Engine, Cloud Run, or any other serverless solutions, you can also link it to your load balancer via this network endpoint group with serverless option. And then there is intranet and hybrid. Well, honestly, those are two different types of network endpoint group. I just put them together because they're relatively similar. And by the way, I don't think that this is all types of network endpoint groups that you can get. I just didn't want to concentrate much on it because I really care only about zonal in scope of this presentation. But anyway, so intranet and hybrid can route traffic if your backend is deployed outside of Google. If it's on-premise, on other cloud provider, doesn't matter. You still can link it and route through the same load balancer as you do route your, serverless solution inside of Google. Okay, let's take a look how this is going to look if we introduce load balancer. First of all, our services, foo and bar, we remove the ingress controller and ingress resources. Our services for foo and bar are now back to cluster IP, meaning that they have private IP address that is accessible only inside of your GKE. But as we remember, because our cluster is in VPC native mode, it means that those IPs are part of our network. So other Google resources that are still in the same project and like in the same network can access them directly using their IP address. And then on top, you can see a part of the load balancer. I will go different direction. So you have the public IP address, you have the forwarding rule and the target proxy that go to the URL map. And then in the URL map, you have defined a couple of backend services that are linked to network endpoint group that is at the end linked to your service. It looks kind of complicated, but if you set this up, and I did set this up with the Terraform, it's not that complicated. You're basically just define the higher level where you have the URL map, target proxy, and forwarding rule. You would also want to use the static public IP address, so it will not change in any way. And then as you deploy more services, you just add additional backends to your URL map and route requests to the places you need. Why I like this approach? First of all, we do have a possibility to route requests based on past as we wanted. And of course, by the way, and of course, we are still using our approach with the Cloud Endpoint. So Cloud Endpoint is still responsible for providing this functionality that we need for security and managing and monitoring and stuff. Just for exposing, we don't use direct Cloud Endpoint, but we use this load balancer. So we still can route bypass. GKE can be created as the private cluster, so GKE nodes don't have public IP address. I personally love it because I'm not worried that someone is going to, I don't know, do what, but I know that my VMs are protected only inside of my VPC and people don't have direct access to it. And then the third option, which is kind of an extension here, because it wasn't part of our, let's say, initial acceptance criteria, but it's very easy to extend because you can use same approach to route traffic to different services. If you want to go to the bucket, then here you go. You have this backend bucket. You can route your traffic there, and you can even deploy your front-end application as a website to the bucket and route it using that load balancer. If you in any time decided, hey, like the GKE is an overkill for this case, so I'm going to use just the serverless solution, then you can do it absolutely invisible for your clients because you are just changing. I mean, you're developing new version of your application in the app engine, like with the serverless solution. And then when it's ready, you just change this URL map to point to your serverless API app engine instead of going directly to the GKE. And that's it. So it's very easy. And also what is important, if you maybe do the transition, I know a lot of projects would run on premise and they want to go to cloud. So this is a very good starting point for making a transition because you can define the load balancer that initially goes to your on-premise resources, and then as you just rewrite them and import to the cloud, you can be invisible to clients, change it and route it to GKE or serverless solutions on the Google. So that's why I really like this approach. Last slide, recap. Now, I know I've been talking a lot, so I want to make a pause and actually think about what we went through. What are like benefits, drawbacks, what each of these solutions give us. First of all, so Cloud Endpoint. Cloud Endpoint provides functionality for API management. With it, you can define your APIs, you can secure your APIs, and you can monitor them. It can be used to expose your APIs, but every API service will get its own IP address, which is again fine. If it works with needs of your project, then just go ahead and use it, especially if you're deploying services that are independent, that are not built in a single system, but you really just provide the API for a bunch of different stuff, then that's an easy, like really easy approach to do it. If you're not okay with that, there is the GKE Ingress. It's a GCP managed solution to expose API deployed on the GKE. It's a feature of the Kubernetes cluster. I know like a lot of people use it, and it's completely fine. You need to understand that GKE Ingress is particularly just an implementation of this Kubernetes feature provided by Google. But you can also use other Ingress providers like Nginx or maybe Istio. So it's also a solution for exposing your APIs, and the good part of it, it's Kubernetes native. So if your application is mostly about Kubernetes itself, then it's probably a very good choice for you. The only thing that if you're decided to use GKE Ingress itself, you need to remember that that it requires your services to have type node port, meaning that your GKE nodes will have to have public IP address. Again, might be absolutely fine for some projects. Yeah, just have to evaluate how it matches to your security, I don't know, definitions and other things. And then there is load balancer, well, a network endpoint group. You need to understand that load balancer is a huge product that gives you a lot of possibilities to actually connect everything to it, literally everything. And if you want to integrate it with GKE, you do have this option because there's network endpoint group that can directly connect to services running inside of the GKE. And not only it, as I said, it can be connected everywhere. Serverless, buckets, Kubernetes, other clouds, on-premise, whatever. Okay, that's all I had for my presentation, but I have prepared some demo in case I will I will finish earlier, and that's exactly what I did. Any questions? Okay, now I'm worried I'm not getting any messages at all because I had like 0 questions. Do you listen to me at all? Okay, still nothing. Okay, and then I'm going to do a small demo here. I have set up like the last approach was the load balancer and the cloud endpoints. Not sure if I will be able to show you everything what I have here. Let's start from the endpoints, from the endpoint services. So in the GCP, you have here. Okay, I don't know where it is. I have pinned it, so okay. Under tools, you have endpoints. And here is like 2 services that I have deployed. You can check, you can open any of them. You can see that they have names are taken from the open APIs I mentioned. Here you have some diagrams where you can see statistics. Well, I wasn't using those services before the demo, that's why I have no data available. Maybe I'll get something. No, let's try a different one. I was doing some testing yesterday, so I was kind of hoping it will show here, but maybe no. Come on. Okay. I didn't. What else you can see here is the deployments. I have only one because that's the one I deployed and it's working fine. If you click on it, you can see when it was started, when it was finished. Also, you can see the YAML configuration. So you see I have here this host defined, and this is the name of our service. I don't have DNS here because I didn't configure DNS using it. And also I have here paths. I've added actuator info, health, and also some custom endpoint that I've added, which is called name. This is cloud endpoints. Now I have a GKE cluster. I have one GKE cluster. I called it VPC Native because I've created in VPC Native mode. It has 2 workloads deployed. This one is additional. Mine too is foo and bar. You can see that type is deployment as we talk about deployments. Each of them has 2 pods associated with them. You can open the deployment and actually see the status of your pods. You can also see like a lot of information here about how much memory and CPU is being used. You can navigate from here to view the logs of your container. And also I have here 2 services deployed. So you can see there again foo and bar services. They both have type of cluster IP, and by the way, the one thing I would like to show you is that they have IP addresses from the VPC network that I have defined because this cluster is in VPC native mode. I have created here one network with one region, and you can see that pods, now let's start from services, that services has a range of 10.130. And if you check the services, you can see that their IP addresses are from that ranges. And same thing for pods. I'm not sure if I can see IP address of a pod here. Okay, it's not here. Okay, we'll take a look on it later from different view. Now let's take a look on our load balancer. So this is our URL map, and you can see that at this point, okay, I really don't like this view, so I'm going to switch to edit mode because I believe it's easier to see all of the configuration there. But you can see that our URL map is using two backend services, one for foo service, another one for bar. And then here you can also see the the routing. So we just define that /foo goes to foo and /bar goes to bar. By the way, what is important here that I've also added a URL rewrite, meaning that if I'm calling my service, like if I'm calling this public URL from the load balancer /foo/name, it will rewrite so it's only /name that is getting to my service. If you don't do it, you might get into situation just seeing that Cloud Endpoint will always return that this API is not supported. And let's actually try to hit it and see how it works. Okay, to find the IP address, you have to go to this advanced menu, and here you can see, by the way, here you can see the forwarding rule, which, as we said, is a link between address and the target. And here you can see a target, which is link between URL map and SSL. I don't have SSL. Okay, so we can open this address. By default, it will say us that this method doesn't exist. By the way, this is actually error response that is being generated by the Cloud Endpoint. And we can try and hit our endpoint with the foo. We'll see that this is the correct service. We can try and go with bar, and we can also see that this is being routed to the correct one. Also, wait, actuator health, yeah, so you can see it's all working. And again, if you do specify something that is not part of our definition, you will get a message from Cloud Endpoint saying that this method doesn't exist and you're not allowed to access it. And let's, by the way, check maybe, because I did call this endpoints, we can see some monitoring on the Cloud Endpoints. It takes some time to propagate, so I'm not sure if we're going to be able to see them, but at least let's try. Maybe it will appear there now. No, still no. It works. I'm using that in production. It does work. It just takes time to propagate. Okay, nothing here too. Anyway, I'm even 1 minute late. I'm sorry.
Hi, thank you for a great presentation. It was amazing. Congratulations on that. And now I'm inviting you to the discussion table together with our participants. So go ahead and have a nice day.